Quadratic inequalities can be quite difficult to get your head around, so I always recommend sketching out the graph first. So we're going to be sketching some quadratics and solving their inequalities today. To solve quadratic inequalities, we will need to sketch them first. So let's remind ourselves of how to do this. The coefficient of the x squared is positive for this quadratic, so the graph will be U-shaped. Notice that we don't know where on the graph it is yet. The number term is 24, so the y-intercept will be 24. Next, we will need to find the roots by solving when the equation equals 0. Let's go through these questions. To answer this question, we can start by solving the quadratic when the sign is equals. And we can factorize this and get each of the brackets equal to 0 to find our solutions or our roots of x equals 2 and x equals 3. And we can use this to sketch the graph of the quadratic. We know the y-intercept will be 6 because the number component is 6, and we know it will be a U-shape because the x squared coefficient is positive. And we've got our roots of 2 and 3. Now, we're told that the inequality is looking for the region where the quadratic is greater than 0. This will be when the graph is above the x-axis. Looking at the graph, this happens when x is less than 2 and when x is greater than 3. Notice it cannot equal those values because the inequality is greater than, not greater than or equal to. We can show this using set notation, but remember to use our union or the or symbol. We're going to start this question by rearranging the quadratic by taking away 6 both sides, and then changing the inequality to an equals and factorising to solve. So our solutions will be minus 3 and 2, so we can use this to sketch the graph because we know the y-intercept will be minus 6 and the graph will be a U-shape. So with the inequality, we're saying that the quadratic is, the inequality says the quadratic will be less than or equal to 0, which will be the bottom half or the bottom part of our graph underneath the x-axis, because that's where it's less than or equal to 0. Notice it can be minus 3 and 2 as a solution. Next, we can focus on our linear inequality by adding 2 to both sides, dividing by 4. So we've got two inequalities here, and we can show them both on our number line. So we're going to first of all put our quadratic one on, so it's anywhere between minus 3 and 2 and including both those values. And our linear one is anything above minus 2 but not including minus 2. So if you have a look at our inequality here, we know that it's got to be minus 2 but not equal to minus 2. It's got to be greater than minus 2, and it's got to be less than or equal to 2. And we can show this in set notation like this. It may be tempting to solve this inequality by multiplying both sides by x. If you were to do this though, we would actually be removing a solution. We would need to multiply both sides by x squared to keep both solutions. Now we can rearrange to make a quadratic. So we're going to take away 3x squared both sides. As we have on the previous questions, we're going to get that as an equals and solve. So we're going to divide out an x from both terms. Our first bracket is just x, and you get that equal to 0 will just be x equals 0. And our second bracket equal to 0, 15 minus 3x equals 0. When you solve that, you get x equals 5. So we're going to draw the graph. Notice that the x squared is a negative now, so it's going to be an upside down u with the roots of 0 and 5. So we know that x can be anywhere between 0 and 5. Now, it can be equal to 0 and 5 apart from the fact that the question says it can't be 0. And the reason it can't be 0 is you can't have a 0 at the bottom of a fraction. Let's not go into why. And if you think the answer would be 0 if the 0 is at the bottom of the fraction, there's textbooks out there to read about why it's not. In set notation, this will be as follows. Let's end with this question. Show that multiplying x equals 1 by x will lead to 1 equaling 0. If you can do that, let me know in the comments below. And you can also come to onmaths.com or click the link in the description where you can access all of our A-level papers and predictions for free, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.